Hello everyone. Welcome to our discussion and explanations for code for activity laboratory 1. We're going to analyze and visualize two fundamental waveforms, a sine wave and a cosine wave, and then combine them to see how signals interact. Let's walk through the code step by step. Let's start with the first part of the code. Here, we import two essential libraries, the NumPy and the Matplotlib. NumPy is for generating numerical data and performing mathematical operations. Matplotlib for plotting and visualizing our signals. These two libraries are widely used in engineering and scientific computing. Next, we create our time base. This line generates a time vector from 0 to 1 second, with a step size of 0.001 seconds or 1 millisecond. Using such a small time step gives us around 1000 sample points, which will make our waveforms appear smooth and detailed when plotted. Next is we generate the signals. In the sine wave, we create 5 Hz sine wave using the equation sine the quantity 2 pi frequency time. This means the signal will complete 5 full cycles within 1 second. A sine wave starts at 0 and smoothly oscillates above and below the horizontal axis. Next is the cosine wave. Now for the cosine wave, we use a frequency of 10 Hz, which is double the frequency of the sine wave. Cosine waves starts at the maximum value at time 0, and since it's 10 Hz, we'll see 10 complete cycles within 1 second. Next is plotting the signals. In the sine wave, we begin by creating the first subplot for the 5 Hz sine wave. The code plots a waveform, fills the area underneath, add labels, titles, grid lines, and even includes the name, which is Carril de la Cruz, and the course BSEC 3 at the top of the graph. When viewed, you'll see 5 smooth oscillations from left to right. For the cosine wave, the second subplot visualizes the 10 Hz cosine wave. Because it has double the frequency, the oscillations appear more compressed. You'll clearly see 10 quick up and down cycles. Again, shading, color, and labels make the graph easy to analyze. Finally, we create the third graph showing the combined signal, which is simply the sum of the sine and the cosine waves. This plot is the most interesting because it contains the slow oscillation of the 5 Hz sine wave and the fast oscillation of the 10 Hz cosine wave, resulting in a complex waveform within varying amplitude and shape. This demonstrates the principle of superposition, which is fundamental in signal processing, electronics, and communications. As you can see here, you will clearly see a slow 5 Hz sine wave, a faster 10 Hz cosine wave, and a combined signal that mixes both behaviors. So to summarize, we generate a time base for a 1 second, created individual sine and cosine waves using NumPy, plotted them with Matplotlib, and combined them to show how two signals interact. This simple example gives us a deeper understanding of how waveforms behave and how multiple signals can be combined, a concept used in audio processing, radio communications, and many engineering applications. Thank you for watching. If you found this helpful, don't forget to like the video, subscribe, and comment what signal you want to visualize next. See you in the next lesson. God bless.